Okay, so today we're still talking about scientific notation. We looked at it yesterday, so we're going to review it a little bit today, and then we'll do a little practice and something a little bit new. Okay, so now you should remember that scientific notation is just a number from 1 to 10 multiplied by a power of 10. So an example of what numbers look like in scientific notation are something like this: 3.2 times 10 to the 4th power, 8.625 times 10 to the 15th power, 5.7 times 10 to the negative 6th power. Okay, as you see, the number has to be from 1 to 10. It has to be at least 1, and it has to be less than 10. It can't be 10. It has to be one digit in front of the decimal place. See, it's just the 5 in front of the decimal, just the 8 in front of the decimal, just the 3 in front of the decimal, and then multiplied by 10 to any power. Okay, this one has a power of 4. That one has 15. This one has a negative 6. Okay, either way. And if you remember from yesterday, if it has a positive exponent, like these two, then it's going to give you a large number. Okay, the larger the exponent, the larger the number. And if it has a negative exponent, then it's going to give you a small number. Okay, and the more negative the exponent, the smaller the number. Okay, so you need to write these numbers in standard form. Okay, in standard notation. Alright, so I'm going to give them to you in scientific notation, and you need to write them in standard notation. Okay, so you've got three numbers, all written in scientific notation. You need to convert them. Okay, so the first thing, if I'm looking at number 1, is I look at the 9. The 9 tells me how far I need to move the decimal. Okay, so I'm going to rewrite this number, 7.02, and then I'm going to move the decimal 9 places. Now, since it's a positive 9, a positive exponent, I know I need a big number. So if I move the decimal to the left, that's going to give me a little number. So I need to move it to the right. Alright, so 9 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where my decimal is going to go. Now, as you can see, I already have a 2 in this slot. A 0 in this slot and a 2 in this slot, and there's nothing in these other slots. So I need to fill them in with zeros. Okay, and then I can erase that first decimal, and there's my number. Now I don't really need that other decimal either, okay, but I do need my commas. So this number, 7.02 times 10 to the 9th power, is really just 7,020,000,000. And that's my answer. And again, I know that that's the right answer because that's a big number and that was a positive exponent. Positive exponents give me large numbers. Alright, so now looking at number 2. Again, I look at the exponent. It tells me I need to move it 5 places. I need to move the decimal 5 places. So I'm going to rewrite my number, 1.5. Now, this time, I have a negative exponent. That means I should get a small number. Well, if I move it to the right like I did on number 1, I'm going to get a big number. So I know I need to move it to the left. So I'm going to move it to the left 5 places. 1, 2, 3, 4, 5. And there's where the decimal goes. And again, I need to fill in all those empty slots with zeros. And anytime you have a decimal that's all the way in the front, you need to go ahead and put a 0 in front of it too, just so it says 0.000015. Okay, and then since I've moved the decimal, I don't need that other decimal back there anymore. Okay, so this is telling me that 1.5 times 10 to the negative 5th power is the same as 0.000015. So that's my answer. And again, I'm checking. It's a small number and it's a negative exponent. So that means I moved the decimal the right way. And on number 3, again, I'm looking at the exponent first. So I'm going to rewrite the number 4.28, and then I know since this is a 3, I have to move the decimal 3 places. And since it's positive, I need to make this big number. So I need to move it to the right. Alright, so 1, 2, 3. So my decimal is going to go here. And again, I need to fill in the empty spots with a 0, and I can erase the other decimal. Okay, and I don't really need the last decimal either. Okay, but I do need my comma. So 4.28 times 10 to the 3rd is equal to 4,280. So that's my answer. And again, checking to make sure I moved it the right way. It's a large number and it's a positive exponent. Okay, now we're just going the other way. This time I'm going to give you a number in standard notation, and you need to write the numbers in scientific notation. Alright, so we've got 3 numbers here. We've got 54 billion, we've got 3,080,000, and we've got 0.00000092. You need to write these all in scientific notation. Alright, so when I'm trying to write things in scientific notation, the first thing I have to do is figure out where the decimal goes. Okay, and the decimal always goes right after the first number. So that's where I'm going to put my decimal. Now, I need to figure out how far did the decimal move to get there. Well, the decimal always starts out at the end of a whole number. So the decimal is right here. So how far did it move to go all the way over here? Well, it went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it moved 10 places. Alright, now with the decimal right there, this number now looks like 5.4, because I can get rid of all those zeros, and it will be times 10 to the 10th place, because this 10 is my exponent. So there's my answer. And to check to make sure I moved the decimal the right way, that exponent is positive, and this started out as a large number. Okay. Now looking at number 2, again, I find where the decimal goes. It always goes right after the first number. So there's my decimal. Okay, how far did it go? It was at the end, so now it moved 1, 2, 3, 4, 5, 6. Okay, so the exponent should be 6. Okay, so I have 3.08 times 10 to the 6th power. Okay, I have to leave this 0 because it's in between two numbers. I don't have to leave these because it's not in between numbers. Okay, so this is my answer. And again, to make sure I counted the right way, that's a positive exponent, and it started out as a large number. Okay, So now, looking at number 3. This one's slightly different because my first number isn't at the front. My first number is all the way back here. That 9 is the first number that's not 0. So the decimal is going to go right after the 9. Well, I see the other decimal. It was all the way over here. So I need to know how far did it go. 1, 2, 3, 4, 5, 6, 7, 8. So it moved 8 places. So that's going to give me 9.2 times 10 to the negative 8th. Okay? But why is the exponent negative? The exponent is negative because it started out as a small number. Okay? I don't have to worry about if I moved it left or right, or if you're going from scientific to standard or anything like that. If it's a small number, it's a negative exponent. If it's a large number, it's a positive exponent. And then the number for the exponent is just how far it moved. It doesn't matter if it went right or left. Okay, now we're going to look at something slightly new. We're going to actually multiply and divide numbers that are written in scientific notation. Okay, so here's an example of the multiplication. Okay, so now I'm trying to multiply 3.6 times 10 to the 4th by 2.8 times 10 to the 3rd. Well, there's a nice easy trick with these. Okay, everything here is multiplying, so I don't have to do it in any specific order because multiplication is commutative. I can multiply the 4 of these in any order I want. So what I can do is I can multiply the two numbers together. So I can multiply the 3.6 and the 2.8. Okay, and I multiply those together. Okay, and that gives me 10.08. So step 1, multiply the numbers. Okay, then I can multiply the tens together. Okay, so 10 to the 4th times 10 to the 3rd. I multiply the tens. And that gives me 10 to the 7th. We should remember that from our exponent rule. You have 10 to the 4th times 10 to the 3rd, so you just add 4 plus 3. That's how I got 10 to the 7th. So, and then these are being multiplied together. So, this looks like it is my answer. And it almost is. Okay, this would be my answer, except this doesn't fit scientific notation because this has 2 digits in front of the decimal. So this doesn't work. Okay, now if it only had 1 digit, then I would be done. This would be my answer. Fairly simple. So step 1, multiply the numbers. Step 2, multiply the tens, and you're done. Unless it doesn't fit because there's not one number in front of the decimal. So we're going to have to fix this. Okay, we're going to have to move that decimal. Okay, I have to take this decimal and move it over here because I can only have 1 digit, so it becomes 1.008. Now, I can't just move a decimal because that would change it. But as we've been doing, we've been moving decimals as long as we change the exponent on the 10, right? So, when you do this, since it has to be the same, if you make this number smaller, then you make this exponent larger. Okay, so if you move the decimal 1 smaller, then you have to move the exponent 1 larger so that it equals out. Okay, so that's 7 turned into an 8. Okay, so here's basically the rule for that if you want to write it down. Okay, and all it is if the decimal gets one smaller, then the exponent gets one larger. That way everything's balanced out. So this is my answer. So again, looking at, we had 3 steps. First, we multiplied the numbers. Second, we multiplied the tens. And then step 3, which you don't always have to do, but sometimes you do, you have to make sure that the number fits scientific notation. So you may have to move the decimal one, and if you move the decimal one smaller, then you got to make the exponent one larger. Okay, so now let's look at a division one. We've got 8.2 times 10 to the negative 5th divided by 9.5 times 10 to the negative 3rd. Now, these steps are basically the same thing, except this time we're just dividing. Okay, so we can just divide the numbers. Divide 8.2 by 9.5. Okay, so just like with multiplying, you multiplied the numbers. This time, we divide the numbers. Okay, and that gives me 0.863. Then, divide the tens. Sound familiar? It's basically the exact same. It's just this time we're dividing instead of multiplying. Okay, and if you remember your exponent rules again, when you divide, you have to subtract. Okay, so 10 to the negative 5th divided by 10 to the negative 3rd. So I do negative 5 minus negative 3. That gives me negative 2. So I get 10 to the negative 2nd power. Okay, so this would be my answer. Except I don't have one number in front of the decimal. So I'm going to have to move this decimal this time, move it this way to where the 8 is in front of it. Okay. And if you think about the last rule we wrote down, if the decimal gets smaller than the exponent gets larger, well, then wouldn't the opposite be the same too? So if we make the decimal one larger, then we make the exponent one smaller. And yes, negative 3 is one smaller than negative 2. Okay, negative 3 is less than negative 2 because negative 2 minus 1 is negative 3. So that did get smaller. Okay, and we can write this one down, but it's really just the opposite. It's kind of like you could just say vice versa to the other rule you wrote down. If the number or the decimal gets bigger, then the exponent gets smaller. Okay, and for example, it has to get the same amount bigger or smaller. So if you move the decimal twice, getting bigger, then you make the exponent 2 bigger. You add 2 to it. Okay, if you move the decimal to make it smaller 3 times, then you take 3 off of the exponent. Okay. Alright, now here's some for you to try. Okay, one multiplication problem and one division problem. Okay, so see if you can do these by yourself. Alright, so let's look at number 1. We're multiplying. Okay, again, like we just said, we're going to multiply the two numbers together first. So 2.1 times 4.1 gives me 8.61. Okay, then I multiply the tens together. 10 to the 5th times 10 to the 10th is 10 to the 15th. And that's my answer. I don't have to change anything this time because there's one number in front of the decimal, so that works out. So I'm done. All right, the second one. I'm going to divide 7.5 divided by 3.5. Okay, that gives me 2.14. I rounded it to 2.14. Okay, then I divide the tens. 10 to the 8th divided by 10 to the 3rd is 10 to the 5th. So there's my answer. This time, again, I don't have to move the decimal because there's already just one number in front of the decimal. So that's my answer. So now we should be able to write numbers in scientific notation and standard notation, and we should be able to multiply and divide numbers written in scientific notation.